Oh, I get to introduce them to my favorite student. Lindsay knows what's coming. Let's see, who is my favorite student? Come on. Oh, you've seen that one already? I showed you that already, did I? Okay, right now my program is freezing and I don't know why. So let's do this. Let's shrink, come back. There we go. For some reason it wouldn't let me move. Let's try that again. Name, good old Ann Surkey. She gets everything right. My favorite kid. All right. It's going to be a half mark each. So what we'll do is we'll mark it through. What I would do probably is just put X's next to the ones that are wrong and then subtract a half mark off of 27 for each wrong X. Or you can count them all up, but I think there's 54 blanks. It's going to be a lot of counting. So as far as I'm concerned, I can give you a limited amount of information, Lena, and you should be able to figure out everything else about the element from your periodic table, your pink periodic table that I know you have in front of you. Yeah, So I should be able to give you the symbol, Li. Well, that's lithium. Lithium. I know it's atomic number 3. That one I've actually got memorized. I know it has 3 protons. Neutrons, well, its mass is 7, so it's got 4 neutrons. How many electrons? 3. How many valence electrons? Ooh, well, I actually have here a little picture of of the Bohr models of lithium, of all the first 18 elements. And I don't know if you can see from the very, very back. Maybe I can zoom in a wee bit. How about zoom in to 400 times. Here is a picture of lithium. It has 3 electrons, 2 on the first shell, 1 on the outer shell. And what's the fancy word for the outer shell that begins with the letter V? Valence. Okay, so it has 1. How can you figure that out without the picture? Well, what row is lithium in? Row, not. Sorry, you know what? You're right. It is in row 2. What column? Thank you. You're correct. What column is lithium in? Column 1. Everything in this column has 1 valence electron. Everything in this column has 2 valence electrons. Everything in column 17 has needs to gain 1 electron. Has 7 valence electrons. It goes a little haywire in the middle, but we'll talk about that. So, a number of valence electrons, 1. What row is lithium in? So, how many electron shells does it have? There you go. What period number is it? Period 2. What family number is it? Family 1. Family numbers are the black numbers on the top of each column in your periodic table.
Where's the dice?
Atomic number 12. So not only can I give you the symbol, I can give you the atomic number. 12 is magnesium. So capital M, lowercase g. Good gosh, spell it right, Mr. Dueck. Magnesium. What's its atomic number? 12. How many protons? 12. How many electrons? 12. I can do those. Neutrons, I got to do some arithmetic. Mass is 24, take away 12. Oh, neutrons is also 12. That's convenient. Number of valence electrons. So I think 2, counting over from the left. Yes? No? Yeah? How many electron shells? What row is magnesium? I think 3. So it's in period 3, family 2. Neon is Ne. It's element number 10, which means it has 10 protons. It also has 10 electrons. How many neutrons does it have? Oh, well, it also has 10. That's rather convenient. How many valence electrons? 8. How many electron shells? 2, because it's in row 2. Sorry, also period 2. And what family is it in? It is in family number 18, the noble gases. We have something with 17 protons. You know what? That's also telling me the atomic number is 17, which is telling me its element chlorine, Cl. How many neutrons? Ooh, I got to do some math. 36 take away 19. How many electrons? 17. How many valence electrons? 7. How many electron shells? 1, 2, 3. Because it's in period 3. And it's in family number 17, which has a special name, the halogens. The halogens. Then we have, something with 13 electrons. Okay, if it's neutral, it also has 13 protons. It also means its atomic number is 13, which means its lucky element number, or our friend Al, aluminum. How many neutrons? 27 take away 13, 14. How many valence electrons? I count from the left. Hey, there's 3 of them. How many electron shells? Well, it's in row 3, period 3. It's got 3 electron shells. 2 full and 1 not full yet. What family is aluminum? Family number 13. 38 proton. What the? Oh, okay. Atomic number 38. Strontium, which is Sr. Right? Yeah, Sr. Strontium. How many neutrons? Ooh, I have no idea. 88, take away 38. 50? Yeah. Is that right? Doing the math in my head. Which is, by the way, you're allowed to, but it's much easier to have a cheap calculator and have it do the math. 38 electrons. How many valence electrons? Count. 1, 2. How many electron shells? Oh, great question. 1, 2, 3, 4, 5. It's in row 5, period 5, family number 2. It's an alkaline earth metal. So that's out of 27 marks, a half mark off for each one you got wrong. You might want to put a quick score in the margin right here out of 27 because it's a little easier to add. Identify the elements whose Bohr model diagrams are shown below and write the names. Okay. Well, what I'm really seeing is 1, 2, 3, 4 electrons, which means this is element number 4, which means it's by the way, I wrote the symbol. If you wrote the name, that's fine. It's beryllium, but I'll take the symbol. B, I see 6 electrons, means 6 protons, carbon. C, I see neon. D, now I got to count. 2 plus 10, 11. Sodium. Nah. 1, 2, 3, 4, 5, 6, 7. Is it chlorine? Is E chlorine? Yeah. I'm counting in a hurry, so if I make a mistake, let me know. Wow. 2 and 8 is 10, and 8 more is 18, 19, 20. Is it calcium? Woohoo. 1 mark for each of those. You can give yourself a little score out of 6 if you want. An element has 76 protons and 114 neutrons. What will its atomic mass be? Well, I got 2 ways to do this. I could say, you know what its mass will be? Its mass is going to be 76 plus 114, which is going to be 190, I think. Or, because I know the number of protons, I could go look it up. It's element number 76, which is osmium, which does have a mass of 190. By the way, 190 what? Grams? No. Kilograms? No. 190 atomic mass units. We actually say, you know what? We'll let one mass be a proton, and we'll use that as our mass reference, which is why the numbers work so nice. 1 mark for that. Can you clearly give yourself a score out of 34 right there? Now, the 2 humans that were away, can you hang on to the quiz? I'll put a temporary NHI. In a couple of days, try the quiz. I will put this answer key online, both as a YouTube video and as a PDF file on pitmath.com. You'll mark it try the quiz in a couple of days, mark it, and then either email me your score or hand it in. Any lawyering with me? Anybody have a question that they're wondering about? Okay. So we said this, why are noble gases so stable? If you look at your board diagrams, and here was the key idea, hopefully you wrote this down, the people that just got the notes today, we said because they have full valence shells, and it seems as though atoms want to have a full valence shell. That's what you would write right here, and this is really, really, really important, it turns out. This explains an awful lot about chemistry. We said this, noble gases have full outer shells so they can't gain or lose electrons easily. In fact, you know what? Not only is it not easy, it's nearly impossible. We can force a couple of them to do it in a lab, but it takes a lot of energy. So basically they can't. Which also means because they can't gain or lose electrons, they can't form compounds. They can't combine with other elements. All other atoms, want a full outer shell. What's the fancy word for outer shell? Valence. I'm going to use that interchangeably. That's a good vocabulary word, so I'm going to keep doing that. So all other atoms want a full valence shell, and they will lose or gain electrons. So if you think about the electron arrangement in chlorine, here's chlorine right here. It could either lose 1, 2, 3, 4, 5, 6, 7 electrons, because it has 7 electrons in its valence shell. Or, to get a full valence shell, it could gain 1. What's easier? Gain 1. Chlorine is going to gain 1 electron. Now, electrons, are they positive or negative? Negative. That's why, next to chlorine, it has a little negative, and there's an invisible 1. It's saying it wants to become, when it turns into an ion, 1 more negative. It wants to gain 1 electron. What about calcium? So calcium is right here. How many electrons does calcium have in its valence shell? Count. 2. So it can either lose 2, or it can gain 16. What's easier, losing 2 electrons or gaining 16? Losing 2. So calcium, to become a stable ion, wants to lose 2. It wants to lose, this 2 plus sitting right here tells you it wants to, first of all, gain or lose 2 electrons, 2 of them. Plus means, oh, it's becoming more positive, it's losing 2 electrons. Now the problem with that, Matteo, is a lot of kids say, oh, 2 plus means you're adding 2 electrons. You're not, you're subtracting 2 electrons because electrons are negative. So what do you notice about the number of electrons lost or gained and the ion charge? We said it tells us the number of electrons gained or lost, and that's what we wrote kind of right here. Atoms become what we call ions. An ion, Amelia, is an atom that no longer has the same number of protons and electrons. An ion is when an atom has lost or gained electrons to get a full valence shell. So, an atom that has lost or gained electrons now has a charge because you don't have the same number of pluses and minuses. It has a charge, and it's called an ion. The charge that forms is shown in the upper right corner of each box in the periodic table. So, to show that something has become an ion, what we do is we draw the Bohr diagram, circles, neutron, all that, removing or adding the electrons as necessary. And then to show that it's an ion, we put square brackets. And I paused here. I think at the bottom of your page right here, it has room, it says, let's draw sulfur. Okay? So you ready? Oh, hey there, good looking. I'm keeping my eye on you. Ah. So we're going to draw a Bohr diagram for an atom of sulfur, and then we're going to draw a Bohr diagram for an ion of sulfur. This goes at the bottom of the first page. So since I'm drawing two pictures, I'm going to divide my page in half. What's the symbol for sulfur? So here, draw a big capital S. What's the symbol for a sulfur ion? This is new. Look up, look up, look up. Here is the symbol for a sulfur ion. S2 negative. Where'd the 2 negative come from? Okay, the charge. And I'm saying this is normally sulfur, but now it's picked up a charge. Okay. You guys okay back there? Yeah? With me here? So, here's sulfur. There's the nucleus. How many protons in sulfur? How many protons in sulfur? 15, so I'll put a little 16p. Sorry if you can't see that, but I put a little 16p in the middle there. How many neutrons in sulfur? Do the math. How many neutrons in sulfur? You guys with me in the back row? Because every time I'm looking, I'm seeing you guys chatting. So cut it out, please. Thank you. How many neutrons in sulfur? Also 16? Okay. What row is sulfur in? Row 1, row 2, row 3, row 4? 3. So it's going to have 1, 2, 3 shells. Because it's in row 3. How many electrons will go in the first shell? In the innermost shell? 2. How can you remember that? Because two elements on the top. So 2, and they pair together right there. 2. Yep. Sort of. The answer, truthfully, is yes and no, depending on what kind of a Bohr diagram that you're doing. But I know on the provincial in grade 10, they tend to pair them together, so I'll teach them to you that way. How many electrons in the next shell? How do you know? By the way, you can either memorize the 2, 8, 8, 18 rule, which is a shortcut. But again, if you blank, you can count. If you count the number of elements in row 2, there's 8. Why? Because each one of those is gaining an electron and a proton. So how many? 8. And this one, Rihanna, I would be fussy on. Can you look up for a second? It's 1, 2, 3, 4, pair, 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 pair. Now you could draw it 2, 2, 2, 2, and I won't know. But what I am saying is if there was like 6, I'd look for 1, 2, 3, 4, and then only 2 of them paired together for 6. How many electrons in its outer shell, its valence shell? 6? Count straight across. Is it 6? Yes. So it's going to be 1, 2, 3, 4. How many more do I need to do? 2 more. Pair them anywhere you want to. I usually continue going around like a clock. I usually start at 12 o'clock and just keep going around. But you could have put them at 9 o'clock and 6 o'clock, whatever. I know there's 2 that are paired and 2 that are by themselves. That we've done already. That is a sulfur atom. Sulfur ion. Now, how do I know it's a sulfur ion? If they say the word ion or if they give me the charge on the symbol. Okay, it's going to start out the same. 16 protons, 16 neutrons. The first shell is going to have 2. The second shell is going to have 1, 2, 3, 4, 5, 6, 7, 8. The third shell used to have 1, 2, 3, 4, 5, 6. This is not stable. It wants a full valence shell. How many electrons does it need to gain to get a full valence shell?
1, 2.
Can you see it from the picture?
I can really see.
Yeah, I know. The bottom, I'm on the blue there, but that's why I went. Can you see it? So I'll do them in a different color. You guys don't need to, but I'll just show you. It has now gained 2 more electrons. So there's 1 there, 1 there. Now it's happy. Now where did it get those electrons from? Some metal somewhere that wanted to get rid of electrons. And then the last thing that we do to show that this is an ion is we put square brackets around the picture and we write the charge in the top right corner, 2 minus. 2 minus. 2 minus. Okay. Let's keep going. So now we're doing notes. And I think now you guys are turning the page. You're on the back of page 1. So, nonmetals form negative ions because they want to gain electrons. Metals form positive ions. And it gets a bit trickier. It turns out some metals can form an ion in more than one way. So nonmetals form negative ions. Metals form positive ions. And some metals can form an ion in more than one way. And you can tell on your periodic table, I'll come back to this in a second, you can tell, take a look, for example, at element 25. Do you notice it has more than one charge? That's saying it can form an ion in more than one way. We have a fancy word for that, Kiana. We say it's multivalent. It's multivalent. There's different ways for it to be stable. And this is where I've told you, Damien, everything I'm teaching you is wrong. It turns out as you get bigger, those electron shells, they actually tangle and overlap, which is why you get some weird stuff going on in the middle of the periodic table. We're not going to get into that much. We will a little bit this year. But at least it's fairly easy to tell. Mitra, multivalent, it's got 2 numbers. Not multivalent, it's got 1 number. This forms a stable ion by losing 3 electrons. This one, titanium, can become stable by losing 3 electrons or 4 electrons. Why? Don't worry about why, but it can. So, copper and iron are also good examples of ions that can form in more than one way. It says draw a Bohr diagram of an aluminum ion and an aluminum atom and an aluminum ion. You know what? Let's divide our page in half again. Okay. Going to show you another way to draw a Bohr diagram. Let's, instead of drawing a huge nucleus, just put a dot there. Mr. Dueck, how can I fit the protons and the neutrons? You know what? Let's write the protons at the bottom. Aluminum, how many protons does it have? 13? I'm just going to write 13p down here, comma. How many neutrons does it have? 14? And the reason I'm showing you that, Dan, is on some of the diagrams that I give you, the nucleus is colored in black. So just write the nucleus, the protons, neutrons beside it or below it, somewhere on the diagram. I'll figure it out. Okay. How many electrons in the first shell? Sorry? 2? How many electrons in the next shell?
8.
Is it 8? Okay. 1, 2, 3, 4, pair, 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 pair. How many electrons in the next shell?
3.
Just 3. This is an atom. How many protons? 13. How many neutrons? 13. This is not stable. How can it become stable? How can it get a full valence shell?
Add,
Add how many?
uh,
Okay, I could add 5 or lose what? What's easier, adding 5 or losing 3? And because this is a metal, it's always going to lose electrons, which, by the way, is how all of our technology and wires works. The fact that metals lose electrons is why they're conductive, which means, yay, electricity technology. That's a good thing. So what's the ion going to look like? We're going to start off with the same kind of an idea. Here's the nucleus. The first shell doesn't change at all. 1, 2.
write 13.
We'll do that at the bottom in a second. I can do that right now to make you happy.
12.
Sure. I should have done that so I don't forget.
Is it 8 plus?
Pardon me?
Is it called
Hang on, I'm going to get there. Good question. I'm changing the order just so that we know exactly kind of how it all fits together. The next shell is going to have 1, 2, 3, 4, 5, 6, 7, 8. Is that okay so far? Once you've got that, put your pencils down for a second. If it was a neutral atom, Tristan, then I would, don't write this down, this next part is wrong. I would do this and I would say 1, 2, 3, but this is not stable. So Kiana, what it has done, it has gotten rid of this electron, this electron, and this electron. In fact, it's gotten rid of this whole valence shell. That there is a picture of an aluminum ion. Still has 13 protons, but how many electrons? Count. Mitra. Louder. You're right. 10. Now, to show that it's an ion, we would put square brackets around it, and we would put the ion charge of aluminum in the corner. What's the ion charge of aluminum?
3 plus.
3 plus. Now, going back to Rihanna's comment, if we were labeling these, I would call this one Al, and I would call this one Al 3 plus. So it's a good system in terms of the labeling. It's not much writing, but you got to really pay attention. Atom, ion, atom, ion. Part of your homework practice is going to be drawing some of these ions as well. Okay? In fact, in Science 10, the phrase that did I say ion? And I say we have to put square brackets in the ion charge, because that's what kids forget. They're so proud of getting the electrons right. Did it? They forget square brackets and ion charge. So, valence electrons. The electrons in the outer shell are called valence electrons. You said that already. If I'm repeating it, probably means it's important. Back to our notes, right? They determine if and how an atom will react. What I'm trying to do to help you guys out is I'm underlining the blanks so you can figure out what goes where. So I've talked about this, but it's so important, I don't mind, Kajal, repeating myself. To determine the number of valence electrons, count over from the left side of the periodic table. I've lied. That trick only works for the first 3 periods. It doesn't work for further down. I'll come back to that in a second. But the reason that these rows, these columns, Rihanna, Aiden, the reason these columns are what they are How many valence electrons does scandium have? 3. Everything in this row has 3. Don't freak out about these. It's a little strange. I'm not going to ask you these very much. I'm not going to ask you, hey, how many valence electrons does tantalum have? I'm not going to ask you that. I'm going to stay in the top 3 rows. So how many valence electrons does silicon have?
0.
Count.
14. 3rd.
Count.
1.
4.
4. How many valence electrons does carbon have?
4.
4. How can carbon get a full outer shell? It can lose 4, or it can, how many?
4.
4. This is why carbon is so special. What's easier, gaining 4 or losing 4? Turns out it can do both, which is why carbon bonds and creates so many different elements, compounds. Silicon is also very similar to carbon, and that's why they left it blank, because it can kind of go both ways. But what's its charge? You can count. 1, 2, 3, 4. If it gains 4 electrons, its charge is 4 minus. If it loses 4, its charge is 4 plus. Back to our notes. Put it in the
Is that on the test? Is it back in what we're
yeah, but I'll make sure it's clear. Like if I ask you about it, I'll make very sure that it's clear which one I want. Okay? Remember that all members of a family, vertical column, have the same number of valence electrons. So F, Cl, Br, and I all have 7. Oh, that didn't work very well as an underline. All have 7 valence electrons. Even though technically you could say, hey, Mr. Dueck, shouldn't iodine have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16? No, it has 7. What I'm showing you works great for the first 3 rows, and then after it goes a bit haywire, but we can still figure stuff out. The periodic table is organized the way it is, partly based on how many protons each element has. That tells you what comes next. But the reason the columns are what they are, it's all about the valence electrons, because that's where all the action is. Next page for me. So, how many valence electrons, and I think I have this yet, I have this for you to answer. How many valence electrons do each of the following atoms have? I want you to try doing this on your own with your pink periodic table. I'll leave this up here in case you don't have your periodic table in front of you, or you can always look back. What's the key? Count for the first 3 rows. If you're further down, look at the top one in your row, in your column. That's the answer. I'm going to freeze the screen. Take 30 seconds to answer this. These are great test questions. See if you get the same answers as me. Magnesium, where are you? Boron. Selenium. I have no idea where selenium is. Here's selenium. Oh, there you are. Tin. Gallium. Where the heck is gallium? Here, gallium. Oh, there you are. I gave you some weird ones on purpose. I'll give you about 10 more seconds and then we'll go over the answers. I got that. The first 3 are fairly straightforward. The next 3 let's talk about. Right here. Element 50, I think. SN.
Oh.
Don't ask me why, but it's Latin. So you ready?
Yeah.
Magnesium, I said, okay, count. Top 3, count. Boron, count. 1, 2, 3. I know it's left blank, but I can count. Chlorine, 1, 2, 3, 4, 5, 6, 7. Top 3 rows I can just count. Soon as you go further down, so selenium, I said, where the heck is selenium? Selenium is, where was selenium?
It's up, like, up more.
It's up, like, up more.
It's like, SE.
I said selenium.
Oh, you just had your finger on it.
Have my finger on it?
No, blue row.
Blue row, right here?
Yeah.
Now, I don't go like this. Instead, I said, how many does oxygen have? How many does oxygen have?
6.
6. 1, 2, 3, 4, 5. So selenium 6.
Wait, isn't it 16?
No, it doesn't work for the next rows. It works for the first 3 rows, and then you go with what's above it. So tin, which is way down here, I'm not going to say blah, 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 it has 4. Also, you'll notice, what's the ion charge on tin? 4. There's another one as well, 4. Gallium, which is right here, it's below boron, 3. 3. Where's selenium? Selenium is 34, element 34. Okay, so
What if it's like, what if you give us one that's somewhere like in the middle? Like
I'm not gonna.
like
I'm not gonna.
manganese?
I'm gonna carefully avoid. I'm gonna give you anything in the top 3 rows, or anything from up to about there, because you can still count up to about there. So I'll give you up to maybe about iron. After that, I'm gonna be very careful what I pick and choose. Okay. So, what are we working on for the remainder of class? First of all, I gave this out a couple of days ago. Can you find this here sheet here, please? So, part of your homework is, as far as I'm concerned, you can now do every one of these. Be very careful to notice the difference between atom and ion. Whenever you're doing an ion, you want to think, is it going to gain or lose electrons? If it's a metal, the left side of the periodic table, it's going to lose electrons, square brackets, full valence shell. If it's a non-metal, it's going to gain electrons, square brackets, charged, full valence shell. I gave you a few extras at the bottom in case you mess up. I do have a couple extra sheets if you really mess up. Also remember to pair electrons as you go along, if you need to. So that's part of your homework. Pardon me?
These are all atoms.
You have to read.
What is atom?
What does that say, my friend? Aluminum what?
Atom.
What does that say? Aluminum what?
Atom.
There you go.
No, I know, but like for atom, it's just a regular.
Atom, just like we've been doing, regular with the same number of protons as electrons. And by the way, because the nucleus, I stole this diagram from a website, which is a great, but since the nucleus is colored in, you can put the number of protons and neutrons beside it or below it or wherever you want to, but somewhere so I can see it fairly easily. Okay, that's part 1. And part 2 is right here. Going to hand this out. Second part of the homework. This one here, section 2.3, isn't due till Tuesday. Tomorrow, by the way, we're done the chapter. Tomorrow is going to be, I'm probably going to give you another take-home quiz on the stuff from today. I'm going to try and put together a study guide. Right now, I think your test on this chapter is probably going to be a week from today. Right now, I'm looking at Thursday of next week, but I'll give you more details as we get closer. What I'd like you all to do, can you look at section 2.3, because I need to explain this chart. Can you look at this one here that I just gave you, section 2.3 homework? I need to explain this chart, okay? This is similar to what I gave you on the quiz, Lena, but I've added one more thing. This question and this question. Now, how can you figure out whether it's an atom or an ion from the ion charge? If it's an atom, its charge will be, that tells you same number of protons and electrons, because it's got no charge. Because you have 16 positives and 16 negatives. What's your charge? 0. Now, if it's an ion, it's going to have a charge. And that means the number of electrons will no longer be the same as the number of protons. It will either have gained or it will have lost. And I'm going to stop there and say, see if you can figure out how many electrons it would have without drawing the diagram. See if you can figure out by counting and understanding whether it's gaining or losing and how many and how close you are to a full valence shell. Dan, if you can get there without having to draw the diagram every time, you're in a good place. So I'm deliberately going to leave you hanging on the rest of this chart to see if you can figure it out. Anyways, you can work on this. Another chart here as well. Drawing some diagrams, answering some questions, and I did attach the answers as... Did I attach the answers? I did not attach the answers. So I'll put the answers on my website, and you all have smartphones, at least one per table. You can access it on the website, and we can save some paper. Okay? Usually I attach the answers. That was different.